Hello students, I am Sachitraka. Welcome to Cars Physics. In this lecture we will discuss relative velocity in two dimensions. Okay, relative velocity in two dimensions. Of course, we have discussed the same heading, means relative velocity in two dimensions in just previous lecture. But in previous lecture we have discussed relative velocity in two dimensions taking rain and man. Means we have discussed how to calculate velocity of rain with respect to man. There are different directions of falling of rain. Rain may fall in vertically downward direction or may fall inclined, mean making some angle with vertical. Man may move on horizontal surface. Man may move on inclined surface. Then in all cases we have discussed how to find velocity of rain with respect to man, relative velocity of rain with respect to man, and of course we have discussed how to hold the umbrella, means at what angle to hold the umbrella so as to save himself from rain. Okay, and we have discussed some numericals also, basic numericals, and I hope you have enjoyed the lecture. So this is also relative velocity on two dimensions, but in this lecture we will discuss river and swimmer, or river, boat, or aeroplane. A swimmer is swimming in river or a boatman is taking his boat in the river, or aeroplane is flying in wind. If aeroplane flies, then there will be resistance due to air or wind resistance. If boat or man move in water, there will be resistance of water or opposition due to water. Okay. Means if a man or boat move inside a river, then there is velocity of flow of river as well as velocity of swimmer or velocity of boat. Okay, we'll discuss. Let's discuss any one of the example, and all numericals will be similar. We'll do some one or two simpler example on the basis of theoretical discussion. Okay. Let's discuss river and swimmer. Swimmer means man. A man swims or a girl swims or a woman swims, whatever may be. You have seen in different athletic events. Okay. Senior, junior, all range of competitions are there, so all can swim. All can swim. Okay. River and swimmer or river and man. Okay. For simpler writing, I am taking let velocity of swimmer is taken as Vm. Velocity of swimmer or velocity of man with respect to river, it may be given, and velocity of river with respect to ground may be given. Okay. Then what we have to calculate? There will be two cases. I am writing the concept. A man is standing. A man is standing on one bank, wishes to reach at opposite bank of a river. So let's take variables first, then we will solve numericals. Let D is equal to width of river V R M. Sorry, VRG. This is velocity of flow of river, flow of water in the river, and VMR, velocity of man or swimmer or boat with respect to velocity of flow of water in river, that is taken as VMR, velocity of swimmer with velocity of flow of water with respect to ground. Velocity of swimmer with respect to river. Okay. D is width of river, VRG is velocity of flow of water with respect to ground, VMR is velocity of swimmer or man with respect to river. Okay. Suppose this is a river. I am showing the surface of river, like this. River is flowing along this direction, let VRG. Velocity of flow of water in river with respect to ground is VRG. River is flowing along this direction, let this is along positive x-axis. Okay. D is width of river. A man is standing a man is standing at one bank, let at A. A man is standing at one bank of river and wishes to reach at opposite bank. There will be two types of discussions. We are discussing number one, first point. The man wishes to reach at opposite bank of river, wishes to reach at opposite bank of river, wishes to reach in shortest possible time. This is our first discussion. Man or swimmer wishes to reach in shortest possible time on the opposite bank of river. The man is at A, wishes to reach at opposite bank in shortest possible time. Okay. Then we have what? First question arises, to reach in opposite bank in shortest possible time. In what direction? In what direction the man should swim? To reach at opposite bank in shortest possible time, in what direction? Means what should be angle of velocity of man with respect to river with ground? Okay. Means what is by aim is what is velocity of swimmer with respect to ground? In what direction he will move, resulting direction, and in what direction he will swim. He will swim along one direction, but finally he will move in some other direction. I am not confusing. Let's see. Okay. In this case, the man should swim here. The man should swim straight across the river. Means velocity of swimmer should be straight across the river. Velocity of swimmer should be straight across the river. River is flowing along this direction and man should swim straight across the river. This is velocity of man with respect to river. Let this point is B. The man will head along this direction. What? The The man wants to reach at opposite bank in shortest possible time. Then he will find this is shortest possible path. Means if he moves along this direction, he will reach at opposite bank, moving in a shorter distance, thus in shorter time. Okay. So the man starts swimming along this direction. Lect. The swimming of man is observed by two observers. One observer is inside the river. This is observer 1. And another observer is standing on the ground. This is observer 2. One observer is observing the swimming of man remaining inside water or inside river, and another observer is standing on the bank of the river or on the ground. Then what observer 1 observes? Observer 1 and swimmer. Observer 1 and swimmer both are in water. Means both are in the frame of river. Means the man who swims and observer 1 are in same frame. That recall. Suppose we both we two friends are moving in sitting in a car. We two friends are moving sitting in a car. Means we both are in car frame. Car is moving, but I am at rest with respect to my friend. Okay. But I am in motion with respect to an observer who is standing on the road. Okay. So, what we will observe? Suppose car is moving with a velocity of 50 km per hour, slow. And a man, means observer, is standing on ground. Means velocity of car with respect to ground is 50 km per hour, and velocity of man with respect to ground is 0. So he will observe that I am moving along with car, means I am moving with a velocity of 50 km per hour. But my friend who is sitting near me, means in car frame, we both are in same frame. Then with respect to my friend, my velocity is 0. You know it. So, observer is inside water and the swimmer is also inside river. So, both are in same frame. So, the observer 1 observes the actual or real velocity of swimmer inside the water. Means observer 1 observes that the man is swimming straight across direction, straight across the river with a velocity v/r. But for observer 2 is standing on ground or on the bank of river. What he will observe? Observer 2 is not in same frame. Observer 2 is not in same frame as that of the swimmer. Swimmer is inside river, inside water, but observer 2 is on ground. Both are not in same frame. So, what observer 2 will see? He sees the swimmer moves along this direction. Not only that, he also sees another velocity is impressed on the swimmer, that is velocity of river. For observer 2, on the swimmer, there are two velocities are acting simultaneously. For observer 2, who is standing on the ground, he will observe that on the swimmer, there are two velocities are acting simultaneously. Means, velocity of swimmer with respect to river, and also velocity of river, means water is flowing. There is effect of velocity of river on the swimmer. So, velocity of river with respect to ground. Okay. So, observer 2 will observe the resulting velocity of man with respect to river and velocity of river with respect to ground. And as we know, If this point is C, then AB and BC, AB and BC are in same order. As you know, if two vectors can be represented in magnitude and direction by the two sides of a triangle taken in same order, here order is clockwise, from A to B, B to C, from A to B, B to C, clockwise order, then resulting velocity is third side of the triangle taken in opposite order. This is velocity of man with respect to ground. This is velocity of man with respect to ground. Means for observer on ground observes that the man is moving along this direction, not along this direction, though this is real direction of swimming of man. The man swims along this direction, means straight across the river. This is straight across the river. The man swims straight across the river to reach at opposite bank in shortest possible time. Means he has to reach at opposite bank quickly. So he swims straight across, thinking that I will reach quicker if I move straight. But actually, when he swims along this direction, velocity of river also impressed on him. The velocity of river will tend to push him or drift him along the direction of flow of water. But he wishes to reach at this point B, means swims, velocity of swimming is along this direction. So there will be two velocities. And this is resultant of two velocities as observed by observer 2. Obviously, the man will not reach at B, because a body moves along the direction of resultant velocity. This is direction of resultant velocity. This is velocity of man with respect to river. This is velocity of river with respect to ground. And resulting velocity directed along AC. The man will reach at C. Then BC. BC is called as distance of drifting. Means flow of river, velocity of flow of river drifts a man, pushes the man along the direction of flow of river. Clear? Then how to find time taken by the man to cross? Time taken to cross the river. Cross the river. Then what is time taken? Let time is t. See, velocity of man with respect to river is given. Suppose it is given. And along the direction of velocity of man with respect to river, distance is d. Then time is equal to distance upon speed. Okay. Then how to calculate distance of drifting? Let distance of drifting BC is equal to d. Distance of drifting. Then distance of drifting is equal to, along direction of BC, speed is VRG, velocity of river with respect to ground, magnitude of VRG, speed into time. Speed into time is equal to distance of drifting and speed, VRG. And time taken by the man to cross the river. During this time, the man is drifted. During this time, the man is drifted along BC. So, time is distance divided by velocity of man with respect to river. This is basic concept. Okay. This can also be done in different way, means by taking help of orthogonal unit vector. I will show you in this numerical. Let's have a numerical on the basis of this theory. The man wishes to reach at opposite bank of a river in shortest possible time. Let's have a numerical. Easier numerical. In shortest possible time. In shortest possible time. This is question. Numerical. A river flows with a speed of any value. We may take let 40 meter per second. Okay, 40 meter per second. A man wishes to reach at opposite bank in shortest possible time. A man wishes to reach the opposite bank in shortest possible time if velocity of swimming of man is 30 meter per second and width of river is 90 meter. Okay, number one, we have to find time to cross the river. Very easy. Find time to cross the river. We have just discussed now. This is river. Okay. Width of river is d. A man wishes to reach at opposite bank. A moves along or swims along this direction. Velocity of man with respect to river. Let BC represents velocity of river with respect to ground, and this is the resulting velocity of man with respect to ground. Okay, at an angle. So time to cross the river, in this case time is equal to distance is d and speed is velocity of man with respect to river. This is time of crossing, means this is shortest possible time to cross the river. We are doing in general way first. So distance 90 meter, speed of man is 30, so time is equal to 3 seconds. Is it clear? Then distance of drifting. As we have discussed, the man will drift from B to C. The distance of drifting is BC. That's equals to velocity of river with respect to ground into time. And velocity of river with respect to ground is 40 meter per second. 40 into time is 3 seconds. That is equals to 120 meter. The easiest way or two easiest way. Okay. Let's now see. Okay. This is one of the method. Now see the diagram. What is, suppose it is asked, what is velocity of man with respect to ground? We will also match this answer. What is velocity of man with respect to ground? See, velocity of man with respect to ground is equal to, this is relative velocity man with relation to ground. So velocity of man with respect to ground means velocity of man with respect to river. See, velocity of man with respect to river plus velocity of river with respect to ground. Okay, but we are finding relative velocity. As we have discussed, relative velocity is calculated taking the method of vector subtraction. Here velocity of man with respect to river, okay, means with respect to flow of river. River can't observe. With respect to flow of river, velocity of river. Velocity of man with respect to velocity of river. Okay. In this concept you should also accept. So this is relative velocity. Then velocity of man. Velocity of man with respect to river, sorry. Velocity of man with respect to river is velocity of man, BMR, means Vm minus Vr, velocity of man with respect to ground minus velocity of river, means flow of river with respect to ground. Velocity of river, R per river. Okay. Then what is resulting velocity? Means velocity of man with respect to ground is velocity of man with respect to river plus velocity of river with respect to ground. So for the man who is observing standing on the bank of river, he observes there are two velocities impressed on the man due to his swimming and due to flow of river. Is it clear? Okay. So if you want to take orthogonal unit vector, see velocity of river with respect to ground is given 40 meter per second. Let's take this is in positive x-axis, so 40 meter per second along positive x-axis I cap. And velocity of man with respect to river, which is given 30 meter per second, this may be taken along positive y-axis, this is along x-axis. So this velocity is 30 meter per second and along positive y-axis means j cap. Velocity of river, velocity of river with respect to ground is 40, okay, and velocity of swimmer means man with respect to ground is 30. So this comes 40 I cap plus 30 j cap. So angle between I cap and j cap is 90 degree. So velocity of man with respect to river, river with respect to ground, then angle between them is 90 degree. Then magnitude of velocity of man with respect to ground is root of dmr, magnitude of man with respect to n square plus vrg square, in square root of 30 square plus 40 square, it will come 50 meter per second. Okay. Man with respect to ground. If it is asked to calculate what is velocity of man with respect to ground, then you can use this method. Okay. Then it is also easier. This method, distance, the speed VMR, distance by speed is time, and this is also drifting distance. Distance into time is drifting distance. Sorry. Speed into time is drifting distance. Okay. So this is easier one than another concept. Okay. Man wishes to reach the opposite bank. Opposite bank, this is case 2, in shortest possible path. River, this is width of river D. Man is at on the one bank of river and wishes to reach at opposite bank in shortest possible path, means without drifting. Shortest possible path means without drifting. Drifting will be 0 for shortest possible path, means directly speaking, the man starts from A, swims from A in such a way that he will reach at B. Just at opposite point, there will be no drifting at all. Okay. So in this case, suppose it is mentioned that man swims. Okay, you first see the concept. Okay. If the man swims along this direction, velocity of man with respect to flow of river, and velocity of river is along this direction, which may be represented from B to C. Velocity of river with respect to ground, and this will be resulting direction of velocity of man with respect to ground as observed by the observer from the bank of river. So the man will reach at B, it will not reach at B. If the man will reach at C, means he will drift, he will not reach at B, means not possible. If the man swims straight across the river, it is not possible to reach at opposite point B, because velocity of river is there. Then in this case, in what direction the man should swim? Okay, let's assume this is velocity of man with respect to river. Let a man swims along this direction. Yes, let AC represents velocity of man with respect to river, making an angle theta with y-axis or making an angle, this is bank of river, 90 plus theta, 90 degree plus theta with bank of river. Then different questions may arise. What is time to cross the river? Okay, this is the condition of no drifting. Why the man will not drift? In this case, then we will go to drifting also. Okay, so why the man should swim at an angle with bank or angle with vertical? Why? See, this is velocity of man with respect to river, represented by AC, and velocity of river with respect to ground may be represented from C to B, BRG. Okay, BRG. The man swims along this direction. Again, if a man is inside the river, means in same frame, he will observe that man is moving along this direction. But for an observer who is standing on the ground, he will observe that on the swimmer there are two velocities impressed, due to himself and other due to flow of water in river. Okay. So again, AC and CB are in same order of two sides of triangle. So VMR, VMG, velocity of man with respect to ground, is a resulting velocity which is directed from A to B. Thus, it will be observed that the man is reaching at B, means in shortest possible time. Okay. Then it is asked, what should the angle of swim? At what angle he should swim? It may be asked to calculate theta or 90 plus theta, whatever may be. And it is also asked, what is time of swimming? So what angle? See, this is velocity of man with respect to rain, making an angle theta with y-axis. This is, let's take along y-axis, and this is along x-axis. Okay. Then velocity of man with respect to, along the direction of AB, means component of MR, along the direction of AB will be VMR cos theta. So, this component represents velocity of man with respect to ground. Just resolve it. VMR theta, the component is VMR cos theta, and the horizontal component is VMR sin theta. Okay. CB represents velocity of river with respect to ground. Let this point is E, then AE represents, okay, CB represents velocity of river with respect to ground, and AE represents velocity of man, means man with respect to ground, VMG sin theta. A represents VMG sin theta, means component of velocity of man, VMR. Velocity of man with respect to the river. Okay. VMR has two components, VMR cos theta and VMR sin theta. VMR sin theta means component of velocity of man, swimmer, with respect to the river along x-axis is VMR sin theta. You may see CB, length of CB is equal to length of A. So length of CB represents velocity of flow of river with respect to ground, magnitude is equal to A, length is same means magnitude of velocity of swimmer with respect to rain is same, but they are opposite in direction means VRG is equal to minus VMR. So sum of VRG plus VMR is equal to 0. So there will be no drifting. See, there is no resulting velocity along the velocity of flow of river. It doesn't mean that if the man starts swimming from A along this direction, along AC, he will just reach at B. No. The man may get drifted. But this is the case of no drifting, without drifting. So I am showing you the condition, under what condition the man is not drifting. Because these two components are same, equal in magnitude, but opposite in direction. So resultant velocity is 0. So there is no resulting velocity along the direction of flow of river. So the magnitude of components is same VRG. Magnitude of VRG is equal to magnitude of VMR. Okay. So VRG, magnitude of velocity of rain with respect to ground, is equal to VMR. VMR. Sorry, VMR sin theta. VMR sin theta. Okay, sorry. VMR sin theta. Then sin theta is equal to velocity of river with respect to ground divided by velocity of swimmer with respect to river. This is the required condition. This is condition for no drifting. This is condition for no drifting. This is motion in shortest possible path without drifting. If magnitude of VRG is equal to magnitude of VMR sin theta, sorry, VMR sin theta, if these two components are equal in magnitude, but obviously they are opposite in direction, so their resulting velocity is 0. So there is no resulting velocity along the flow of river or opposite to the direction of flow of river. So there will be no drifting. Okay. So condition is satisfied. Then time of crossing the river C. Distance is AB. This is distance of crossing. Means shortest possible path. This is direction of resulting velocity divided by velocity of man with respect to ground. Okay, magnitude of velocity. Then you know Vmg is equal to Vmr cos theta. Also, if you use Pythagoras theorem, this angle is 90 degree. This is base, this is perpendicular, and this is hypotenuse. Length represents magnitude. Then Vmg, magnitude of velocity of swimmer with respect to ground, is square root of Vmr square minus Vrg square. Hypotenuse, this is perpendicular, this is base, thus Vmr square minus Vrg square. You may calculate in this way also. After calculating magnitude of velocity of man with respect to ground, means component of man, velocity of man with respect to ground, just across the river, okay. After calculating Vmg cos theta, sorry, again cos theta, Vmg is equal to Vmr cos theta. Vrg is equal to Vmr sin theta. Okay. Sin theta. Okay. Vmr square minus Vrg square, you can calculate either this way or straight taking Vmr cos theta. Then divide the speed. D divided by speed gives us time of crossing. It is easier. Okay. Then drifting. Under what condition there will be drifting. See the condition, see here, these two magnitudes are same. VRG is equal to VMR sin theta if velocity of rain with respect to ground is greater than magnitude of velocity with respect to ground is greater than the component of velocity of man with respect to ground means VMR sin theta. If this happens, then there will be drifting along the direction of flow of river. What is distance of drifting? Suppose this velocity is more now, then this velocity is more. This is magnitude of Vm sin theta and this total length is magnitude of Vrg. So obviously this will be resulting velocity. So man will reach at B dash. Then dV dash is distance of drifting. Then distance of drifting will be resulting velocity along the flow of river. Velocity of river with respect to ground, and in opposite direction there is VMR sin theta. These two are opposite in direction. Magnitude of Vrg is more, minus VMR sin theta. This is the resulting speed along the direction of flow of river into time. Means time of crossing. Of course, you may calculate here time of crossing like this t, putting VMR cos theta square root of VMR square minus VRG square. Then put here the value of time, you can get distance of drifting this much. Let's have a numerical so that will feel more easier. Okay. Suppose question, will I write or I will show? Okay. Just I am showing you, you can understand. River, velocity of flow of river with respect to ground, okay. In shortest possible path or second discussion. This point is A, this point is B, okay. In shortest possible path, with or without drifting, we will see the both concept. First we will take without drifting, okay. A man starts swimming along this direction, means this is velocity of man with respect to river. Let this angle is 53 degree. Making an angle 53 degree with y-axis or with vertical, and total angle with bank of river is 90 degree plus 53. The man starts swimming along this direction, okay. So velocity of man is represented by AC, direction is from A to C. First, no drifting, there is no drifting. For no drifting, we will have numerical. Then CB represents velocity of river with respect to ground, and resulting velocity is along AB, velocity of swimmer or man with respect to ground. Is it clear? Then we have to find time of crossing the river. In shortest possible path, time of crossing, there is no drifting, we have shown no drifting, and here it is given velocity of man with respect to river, means magnitude of velocity of man with respect to river is 80 meter per second. 80 meter per second, and velocity of river with respect to ground is given. Let this is 64 meter per second. Okay. Then it is asked to find time of crossing. As you know, time is equal to, if width of river is d, distance y, velocity of man with respect to ground, magnitude of this velocity, and where velocity of man with respect to ground, either you may take V mr cos theta, here theta is 53 degree, or V mg is equal to Vmg is equal to square root of Vmr square minus Vrg square. Answer will same. This is easier, you can calculate this way. Vmg is equal to Vmr, velocity of man with respect to rain is 80, cos theta, theta is 53. See, this is 4 meter, this is 3 meter, this is 3 meter, and this is 5 meters. This angle is 90 degree, this angle is theta. Then you require cos theta, here cos theta is, here theta is 53 degree, and cos theta is 3 divided by 5, base upon hypotenuse 3 by 5, so 80 into 3 by 5, this is 48 meter per second. Okay. So velocity of man with respect to ground is 48, then time of crossing is the distance by velocity of man with respect to ground. Of course, if you put these data, means velocity of man and velocity of river here, you will get the same answer, right? Okay. Then time is distance upon resulting speed across the river. Then width of river, have I written? No, I have not written. Okay. Given D is equal to, means width of river, you may take a value, let 240 meter. Let width of river is 240 meter and this is 48, then this is 240 meter divided by 48 meter per second. Then 240 divided by 45, 5 into 8, 40. Okay. This will come 5 seconds. Time of crossing is 5 seconds without drifting. Okay. Suppose it is asked, I am writing here, if velocity of river with respect to ground, okay, velocity of river with respect to ground, let it is 84 meter per second. Velocity of river with respect to ground we have taken 64 meter per second. Now we do consider it is 64 meter per second. In this case, magnitude of velocity of river with respect to ground is more than this component. This component is V mr sin 53. So here V mr sin 53. Vrg is more because VMR sin 53, we have calculated, no, we have not calculated, this is cos component, VMR cos theta is 3 by 5, so sin component VMR sin theta. Velocity of man with respect to river is 80 and sin theta is 4, perpendicular upon hypotenuse 4 by 5, and this will be (16 into 4). This is also 64 meter per second. Okay, we have calculated. I think we have calculated. Okay, it is 64 meter per second. This is also gives same 64 meter per second. So there was no drifting. If these two are same, there is no drifting. So in this case, previously Vrg is equal to Vmr sin theta. Both are 64 and 64 meter per second. So there is no drifting. Both cancel each other. But here we have taken, this is not 64. These two length of lines are not same. But velocity of river with respect to ground may be shifted to V dash. Means CV dash represents velocity of river with respect to ground, which magnitude is 84 meter per second. But this component VMR sin theta VMR sin theta is only 64. Along negative x-axis 64, along positive x-axis 84. So resulting velocity along the flow of river is equal to VRG minus VMR sin 53. This is along positive x-axis I cap and this is minus j cap. So difference between them is VRG, velocity of river with respect to ground. We have taken 64. No, here we have taken 84. This is condition for drifting. 84 minus velocity of man with respect to river, the component sin 53. We have taken sin 53 4 by 5 means 64. So resulting speed is 20 meters per second. So distance of drifting is this much. The man will reach at B dash, he will not reach at B. He will not reach at B, he will reach at B dash, then this much distance is drifting. This is just opposite point, this angle 53. So this is distance of drifting. So distance of drifting is resulting speed into time. So distance is equal to resulting speed is 20 and time is 5 means 100 meters. This is distance of drifting. If VRG, speed of flow of river with respect to ground is given 84. For no drifting we have taken 64. If 84 is increased value, then there will be drifting along the flow of river and drifting distance is 100 meters. Okay. Thanks my dear children. In next lecture I will meet you with a beautiful and applicable conceptual chapter. Thanks.